Hi Year 11 and welcome to your lesson on exercise 9.02, which is titled Using Straight Line Graphs. Last lesson we looked at our straight line graphs, the formula for it, and how we can determine things like the gradient and y-intercept from a formula, as well as a bunch of different things. So we're going to be looking at these in like a real life situation now, or a situation that we can apply a linear relationship to. So our first example is the concentration of a particular drug in a person's body decreases as time passes, which means it gets less and less. This is represented by the graph shown, which has the equation C equals negative 25t plus 200. Note that the variables x and y have been replaced by t and c respectively. So c is for our drug concentration and t is for time in hours. So what is the gradient of the line? So when we look at what the textbook's done, they've actually found their rise and run. But we learned about how y equals mx plus c, so we can just, let me change that to red. We can just look at our formula and see that it is negative 25. If you prefer to do this where they go, well, I'm going 5 across and 125 up, I'm going to do it's going down because remember we read from left to right, so it's going to be negative 125 over 5, which will give us negative 25. Or you can just read it to the formula. I'm happy with either. What does the gradient represent? So the gradient represents the decrease in drug concentration per hour. So we could say it goes down by 25 micrograms per milliliter every hour. Part C is find the vertical intercept. So remember vertical is up and down, which is going to be this one here, or our y-intercept, or in this case our c-intercept. So we can read it off the graph, or again we can look at our formula and it's going to be 200. D is what does the vertical intercept represent? So it represents the initial concentration. So when time equals 0, we can see that our concentration equals 200. Finally, when will there be no drug remaining in the body? So I don't particularly love the way they've done it, but that's all right. I'll do it my way as well and step it out a bit more for you. So we want concentration to equal 0. So we're going to say let C equal 0. Remembering our formula is C equals negative 25t plus 200. So we're going to say 0 equals negative 25t plus 200. Now I want to get the t on its own, but in this case, at the moment, our variable in front of t is a negative. So what I'm actually going to do is add 25t to both sides. That's going to cancel out this side and leave us with 25t equals 200, which is great because now both are positive. Remembering there's a little times in here, so we're just going to divide each side by 25. Cancel, so t is going to equal 8 hours. Which makes sense because we're down to 25 at 7 hours and we're decreasing by 25 an hour, so by the time we hit 8 we'll have 0 micrograms per milliliter in the blood. Alright, our second example is Carly has a window cleaning business. Each day it costs her an average of $75 for fuel and car maintenance and $8 per job. We're going to let C equal Carly's daily cost in dollars and n the number of jobs she does per day. So we want to write an equation. So if we think about this $75 for fuel and for car maintenance, she has to pay that every day. And that doesn't matter if she's got 1 job or 100 jobs. That's just what the starting price is going to be. So we're going to have this 75. That doesn't have a variable attached because that's just our maintenance and fuel cost. It's then going to cost her $8 per job. Now, if we were doing 2 jobs, we would do, say, 2 times 8, which is 16, plus our 75. But we want to have it with n in it so that we can substitute any number. So we're going to do our $8 times n, our number of jobs. So we can then write that as cost equals 8 times the number of jobs plus 75. That's our equation written. The second one is to construct a graph to illustrate Carly's daily costs. So we're not going to go into negative because she can't do negative jobs. So we're just going to go from 0 and include 1, 2, 3, and 4. All we're going to do is substitute in. So C equals 75 plus 8 times 0 is going to be 75 plus 0, which is 75. So that's this one here. For 1, we're going to say C equals 75 plus 8 times 1, which is 75 plus 8, which equals 83. So we're just substituting each of these number of jobs into our cost formula to fill out our table. We're then going to create our Cartesian plane and we're going to plot those points so we get something that looks like this. Finally, what is the gradient and vertical intercept of the graph and what do these values represent? So again, we could go off our formula and do the calculation, but we know that this here is our gradient or our m value, so it's going to be 8, and this is our vertical or y-intercept or our c value. So we can say the gradient is 8 and the vertical intercept is 75. The gradient represents Carly's cost per job. The vertical intercept represents Carly's fixed daily costs, or the costs without doing any jobs. Alright, I've got some questions for you now to do out of exercise 9.02. Let me know if you need any help.